Let's look at some examples. For this first couple of examples, all we want to answer is how many roots does this function have? We're not asked to look at a graph and figure out how many real or imaginary or any of that. We just want to know how many does it have. And remember that that's based on the degree. So you want to look all the way across your polynomial. Don't assume that it's in standard form. It might not be. This one happens to be. Find your biggest exponent. Your biggest exponent defines the degree. So in this case, my degree is 3. So I am expecting to have 3 solutions. It's as easy as that. My second one, here's one that is not in standard form. Notice the sneaky x to the 4th hanging out in the middle here. But that is still my degree because it's my biggest exponent. So even though it's not in standard form, don't let that trick you. My degree is 4. So that means that the number of solutions, again, not talking real, imaginary, anything, but the total number of solutions is 4. Finally, let's look at some graphs and identify how many real and imaginary solutions that I have. So this first graph, I can tell that it's an even function because I have arrows that would go down here and here. In fact, you could even draw those if you wanted to. And we are told that it's a degree 4. So if it's a degree 4, I am expecting 4 solutions. How many can I see here? I only see 1, 2. So if I see 2 solutions, that means that I have 2 that are real because those are ones that I can see on the graph. And since I need a total of 4, that must mean that I also have 2 imaginary. So that 2 plus 2 is equal to 4. Finally, we are given a third degree polynomial. Again, we knew it was an odd degree because I can see that my graph is headed this direction. And in this case, I notice that I have one place where I cross the x-axis. It's not a bounce, it's just a crossing. So that means that I have 1 real solution. If I have 1 real and I need 3 total, then 2 must be imaginary.